want to be very clear, I do still have the utmost animosity toward both Red Bull Racing and the Oregon Ducks. Like, despise both of them to an absurd level. All right, cool. So we are graphing these, and we have the original, and we have the simplified form. And this morning I added one more. So we really have the factored form, and then when we divide out, it's simplified. So we did all this stuff yesterday. Now, with graphing these, here's my suggestion. We only really truly need the information that's here. And if we have to get another point, we can, and we'll talk about how do we get that. But right now, as I'm looking at this graph, I'm thinking in a few different directions. And obviously, I have to think horizontally and vertically, x's and y's. I'm trying to decide whether I want my x-axis to go all the way through, or if I want it to be heavy on one side or the other side or whatever. That's what I'm trying to decide. How far to the left is the leftmost value that I have out of any of this? -3. And I want to be able to see past that. So I might go out to -5 or -6. The scale doesn't really matter as long as I can see on both sides of it. I'm going to commit to just out to -6. You do not have to change yours. And I don't even really need to commit to -6 truly, because I know that if I just pick, I don't know, if I say this is 3, would you believe me? Sure, especially if I do this and do -3. Now, if I put a -3 over here and I have room, I'm going to put what number right here? 3, because it's the same scale. Now, if you've heard me say, make the scale square, I know I say it, I don't know if I've said it a lot in here because we haven't graphed a bit. Do you know what I mean, Ken? If I said, I want the scale of this thing to be square. So doubled is a good thought because you're thinking like x squared. Here's what I'm actually thinking. If this is a distance of 3, I tried pretty hard just sketching it to make that the same distance, right? If I go up that amount, which is roughly here, what distance do you think I should say I've gone up? It's reasonable. Now, if I had had this, and we didn't, but if this had been 12, would I have jumped by 3 that time? If my y-intercept or axis, sorry, yeah, I'm just doing it right now. If this had been, instead of y equals 1, if this had been y equals 12, would I still make this a 3? No, I'd probably make that like a 10. And I would change my scale, right? And it wouldn't be square, just so I could see it. If you want it square, you can always make it square. I'm fine with that. So if that's +3, this must be approximately what? -3. One of the biggest issues that I see with people graphing, and you guys are kind of past it, I haven't seen a whole lot of this issue, is that pretty commonly when somebody's setting up their x scale, this happens. 1, 2, 3, and it drives me up a wall, just first and foremost. But it happens. It's common. We want it to be consistent. Okay, so double check for me. Do you have your x and y axes labeled? If you don't, label them now. Now, I have benefit here because I have colors and things. I have a million color pencils if anybody wants some. If you don't, highlighters, probably. I'm going to draw my asymptotes. Now, I'm going to just keep them as solid pink lines because I'll just be consistent with it. You guys hoot and holler when you think I'm at x equals 1. Okay, deal. Am I ever going to touch this line?
No.
No, and what did we just draw? And that's the VA. It's not my x-axis. This is my x-axis, hence the x here. And that sounded snarky, but that was not intended to be. This is my vertical asymptote. Okay, anything else I could draw on this? So y equals 1 is about here-ish. So I'm going to draw a horizontal line through there, and I'll make sure that I label it y equals 1. If we don't label anything, you're never going to know if this is the origin or if this is the origin. Label like your life depends on it, or that your test score depends on it. Cool. All right, so we have all that. Any other values that I can put on this graph? So we'll just say taken care of. Taken care of. So the whole I'll put on here in a second, because that's and that's an interesting thought. The whole is actually the exact opposite of a point on the graph. Kind of, right? Hit it.
Why did you not dash the lines?
Because I have colored pencils or colored markers, and if I'm going to be consistent, I'm okay with it. But if you'd prefer me to dash them so that yours are also dashed, I'm cool with it. I mean, you have an eraser.
Yeah, but it just doesn't look as good.
You can't see. I was picking up the pen. Anyway, all right. I need another point.
What?
What do you mean 1? Why? So let me rephrase that. I need another point that we've already done the work for. We did the asymptote. We did this asymptote. I'm going to hold off on the whole for a minute. Holy cow. This is a point on my graph. It's right here. Like it's the x-intercept. Is everybody okay with where we're at here? Okay, here's my question for you. Or I want you to actually argue this. I'm going to make a statement. I know enough about this graph to draw it right now. Do you?
Yes.
How?
Because you move 3 over, like, to the right. You go 3 because you need to have an extra point. But you can't move up or down because y is 0.
So we're going to pause. I don't quite understand what you said there.
You remember yesterday when we did that thing where our graph was next to 3 and it was like up there and it was, I think it was 1 over, or 1 up, 1 over. And then to get another point, we did 1 up.
So we did, but huge, good call. Better memory than I have. There's a very big difference between this function that we did that with the 1 up or 2 up or 1 over, whatever, and this function. The one we did yesterday was linear. This one's going to be more like the alpha welding symbol. One of those things. Okay, which, tell your mom I'm still waiting for a hat. Okay, looking at this, here's my suggestion. Talk with your neighbors. If we don't have enough points right now for you to see what this graph looks like, how do we get a couple extra? And maybe we'll just talk as a whole class since there's only 6 of us. So that's really good if we have a straight line, but we have a fraction here.
What did you say over there?
I came back because I wanted to hear what you were saying. Any of you guys feel comfortable that you know what this graph should look like? No, like that's what I want. Just so you know, that is exactly what I want to hear. Check it. No, you're going to learn, and we'll get there. If we need a few extra points, it's not the end of the world. We could make a big table, but we don't really have to make a table. What's the name of the function that we're graphing? The single letter. X is the variable. F is my function, right? So what I'm going to do is I'm going to do a little bit of scratch work, and I want you guys to add this. If you can't see what the graph is going to look like yet, we're going to get a few extra points. Now, as we go through this, remember, you don't have to write everything that I do. I'm going to try to make sure I write it so it's accessible to everybody, but if you see what I'm writing, you go, I don't need that. Just don't write it. That's fine with me. We want some extra points. I just want to be able to put some more plots on here. So let's pick some easy values. I'm going to find F, right? So we're going to plug X values into F. So pick some X values, and I wish I could be more specific, but I'll help you work out what these are going to be. Some X values, and plug in. Ooh, so you're about to see a weakness in my grammar and just word structure. It's one word when I say into, right? If I say plug this into this, it's still one word. Oh, goodness gracious. It feels wrong. Plug into. Now, we can make a decision here. We can plug it into our original equation 1 that we labeled yesterday, or we can plug it into the simplified version 2 of it. Are they going to be any different? So who would you rather plug into? 1 or 2? 2 is much simpler to deal with. Let's plug it into the simplified version. So I'm going to say into equation 2. Now, just so you guys are aware, we're skipping the table. We're not going to make a formal table here, but we're just going to get a little bit of extra. The only point that I have on this graph right now is when x is -3. So let's pick some other x values. So I know that it's going to be f of, and I'm going to copy this because I can do that. You guys can't, unfortunately. It's something plus 3 over, and I'm doing something, I'm just leaving it blank, x minus 1. So something minus 1. Now I'm leaving this blank because you guys are just going to help me pick some x's to plug in here. So let's just get a few points. And if you're comfortable with like 2 points, awesome. If it takes 10 more points, we should talk. We shouldn't use 10, but we can make it easier than just 2. Give me any other x value that I allowed to plug in here. 2, like all the way over here? Or -2? Is there an easier value that I could pick first? 0 is always going to be if I can pick it. One value I can't pick. I can't pick -1. Why? there's a hole there. Like we just can't do it. So let's try it out. Let's pick 0, which means I'm going to plug in 0 for x, and I'm going to plug in a 0 for every x. And I just want to, if it's not clear, these are the same thing. I'm just replacing the x. So help me out here. When I plug in a 0, and I'm going to write this as an ordered pair is what I'll do. I plug in a 0, and you guys are going to help me figure out what it spits out. In the numerator, it's 0 plus 3, which is over 0 minus 1. What's 3 over negative 1? Negative 3. When I plug in 0, it gives me a negative 3. Everybody cool with that idea? Now, it's just like we made a table. We're just not making the big table. I'm going to plot the point 0. And what value is it? When I add that point, can you tell me what that part of the graph looks like now, do you think? Yeah. Walk me through it. I'm going to be here. I'm going to start working to the right. Am I above the axis or below it, Desi? Why do I have to? I agree. I have to be below. And you're going to see, if you're drawing with pen, be very careful when we get to negative 1. And we'll see why. I know that this is going to go from here to here. And it's going to get how close to that asymptote? So close. Am I actually going to cross it? No, because if you cross it, you lose your points. You're not allowed to cross it. How close am I going to get to this asymptote on the other side of it? Close. Now, my graph isn't perfect, and I'm going to try to make it a little bit nicer. Because the horizontal asymptote means this is the y value we get really close to as we get further and further away. Like, that's what it is defined as. So I know that I get really close to this one, and I get really close to this one. Now, it's not happening very fast on my graph, but does it look like my values are getting close to that dashed line? Okay. On the other side, like one more point is all that we needed here. Now, before I forget, what was the weirdness that happened right here at negative 1? So all I'm going to do is I'm going to go down to my graph. I'm going to erase it. I'm going to make a hole. So it's very clear that it's there. We are better at graphing the Desmos, and I legitimately believe that. You can't see this on Desmos. Okay. On the other side, we have 2 options is what I see. And now, without plugging in points, and we will plug in points if we need to, but I'm going to give you guys a thought. Don't draw both of these. I want to know which and why. Is it option A, do you think, or is it option B? Talk it out with your neighbor. I want an argument. So we're actually going to try this. What's up? The other part of the graph. Because it can't be both. It's only one of them. Here's what I want you to do. One game of rock, paper, scissors. Whoever wins. Did we do this in here yet? Okay. Should we make it mathier than that? So we're going to. Good call. All right. It's not really that much mathier. What I've been having other classes do is when I say you guys talk, it gets really loud, which is fine if everybody's talking. You guys ever zone out and you just kind of let the other partner talk the whole time? For sure. Like I've watched you all do it. You've all done it. Like it happens. I get it. Other classes have had to play rock, paper, scissors, and whoever wins gets to decide. Are you going to explain your answer to your teammate while they listen, or are they going to explain it to you? The winner decides. So we can do it instead of rock, paper, scissors. Here's a different game. We can play even and odd instead. So check this out. I'm going to show you a new game, another way to pick. So I don't care who picks, but check it out. Beatrice, do you want to pick or do you want me to?
I'll pick.
Okay, so I'm going to put one hand behind my back, which has in between 0 and 5 fingers up. I'm going to hold up some number of fingers on my back. You do the same.
Any number?
Yep, 1, 0 through 5. All you have to do is, I don't really care what it is. Pick even or odd. That's all you got to do. Hold up your numbers.
Oh.
It's 4, which is even. I win. So I would get to say, I want to explain it to Beatrice, or B, I want you to explain it to me. I want you guys to play a round of even and odd with your neighbor. I don't care who picks. I'll just decide. We'll say, you know what? I will decide. This side is picking even or odd, just so you guys know. So Kian, you're picking. Wenzel, you're picking. Beatrice, you're picking. 0 through 5 on one hand. The person on that side picks even or odd. If you're right, you get to decide who speaks. So Kian, you get to decide, are you explaining whether A or B is right to yell or vice versa?
No.
So I take it you won, B? You won? Are you explaining it or is Lucy explaining it? Okay, Lucy, explain it. You cannot comment on their explanation until after they've finished their explanation.
Am I explaining to the whole class or like?
Just to your partner. So yell, I already heard you explain it, but I didn't hear what you said.
No, I won.
What do you think? I didn't catch your explanation, that's all.
So I think
Wait, what does it mean? Like A and B.
So it's
Why?
the other part of the graph is either A or B. It can't be both because remember a function has to have one y value that it pairs with. I fail the vertical line test all through if these are both here. So it's either just this or it's just this. And I want to know. We've already decided this is what we've already locked the other side in with. Like I know it's this already. So I'm just trying to decide which one is here and why. What do you think? Well, that's what the question right now is. What did y'all say?
I think you're right, but your
And why?
reasoning is a little out there.
I have two theories.
Okay. Go ahead.
My first theory is when you said that it was gonna look more like an alpha welding symbol, the alpha welding symbol would be A because it goes like boom, boom, diagonal.
So let me follow up. I didn't know if Alpha Welding did this or this, just for the record. So I had no idea which one it was. I just knew it was one of those. What's your other theory?
The other theory is it would be A because it's like opposite. Like it like flips.
Okay.
Or whatever you would call it.
So you're stuck on A. You think it's A.
I thought.
Do you agree?
Honestly, I probably agree.
I think I do, but I'm looking for a better explanation. Like
I agree,
your
but I
your
don't
reason's
know.
good.
I know that I think A is, but I don't know why.
Okay.
Think that.
We're gonna clean it up and we're gonna see. Gut feeling, Ken. What do you think? What did you think? Why? Okay. So yeah, what's the other part of the graph? Okay. Couple things that we're going to go through here. And looking at this, this is the logic that I would recommend we think with. Real quickly, when does a graph touch the x-axis? What do we call that number? Like this is special. It's a what? No, it's not. Now keep your answer. It's a 0. Give me another word for this.
Roots.
0, root, solution, or x-intercept, right? Okay. For this language, hopefully we have locked in. If you don't yet, these are all equivalent for our purposes. Here's the follow-up. And if you're zoning out right now, please try to tune in because this is a really important idea. How many x-intercepts did we find on this whole graph? Where we literally only found this one, right? Which means where's the only place that it can possibly touch the x-axis? Is it ever going to touch anywhere but -3? No. So why can't it be this one? So get that out. I just want you to, we'll do the same thing. Hoot and holler when I know that we've graphed the wrong thing. It's not yet.
Wrong.
How do I know it's wrong right now? If it's so, it's not -3, but there's even a bigger part. Beatrice, what were you going to say?
I don't know. It felt like it was wrong, but I don't know why.
So let's clean this up. What did you think, Gail?
It's not a big touch.
Yeah. How many places did we find the x-intercept to be at? There's only one spot, right?
Yeah.
Does this side of it touch the x-axis?
Yeah.
Like right now it is, right? But did we find an x-intercept over here? No. It can't touch it again. This is the only place that it's going to touch the x-axis because we already found that. It can't touch again. This one does, doesn't it? So if it can't be this one, it must have been this one up here. We need another part of the graph that doesn't touch the x-axis. Because this is the only place I'll ever touch the x-axis. I can't touch it again. Now, if you still hear that and you don't like it, there's good news. This is the fastest way to do it that I know of. But there's other ways. I need to know if I look at this graph, and I don't care if we call it A or B, I know that if I plug in 3, am I expecting a y value that's positive or negative based on this graph right now? It should be positive, right? So let's just check real quick. And we're going to go back to here. I want to do one more. I want us to check something over here. Something to the right of this asymptote. Any x value would suffice. Something to the right. Kian, go ahead.
What if there's 2 x-intercepts?
Then we would touch twice.
That would be the answer.
Yep, and we would, all we're doing right now is we've already done everything hard except we're trying to figure out what the other part is. Give me another value over here, because we already have the left half, and when I say that, I mean left of the asymptote figured out. Give me any x value on the right half. It has to be an x value. 1, I like it, but it won't work. -2 is not to the right of it.
3.
Positive 2, 3, those are both great. 50 million is also good, or 7. Yeah, 6, 7 also works. Let's do, what's the easiest known? Something bigger than 1. 2. Let's just try it. 2 and 2, right? When I plug in a 2 into this function, what does it give me? What's 2 plus 3? Over 1? So if we didn't know and we don't like the idea of just using the roots, it's okay. I now know that if I go to 2, I get the 0.5. Have I already just now, by doing that, locked myself into that region? That's 2, 5. This is that point we just found. Is there any chance that it's this now? Does that run through this point that we just said has to be on the graph? So I lost. You let me back up 1. Go ahead, Ken. Nope. -3, I already knew it was here. Like, we can verify that. If we do f of -3, you're going to get 0. Guaranteed. I only picked 2 points over here. Should we just commit to doing it maybe not quite as efficient, but getting a few extra points? All right. So we'll do that. Help me out with another point. I'm trying to do the right side still. And we just did 2, right? When it was a 2, I plug in a 2 and it spits out a what? Are you sure? 5 over 1 is positive 5. Which means if I go to 2, 5, do you agree that it's roughly here? Yeah. And I'm just looking, it's because it's where x is 2 and this is 5. If I still can't tell what it is, give me another value to the right of this. F of what, maybe? Pick something bigger than 2 is all we're trying to pick. 3, sure. If I plug in a 3, what do I get? 6 over 2. So we just said if I plug in a 3, what's 6 over 2? 3. And all I'm doing is I'm picking x value. So when I plug in a 3, what does it spit out at me? If I look at this point, if I pick x as 3, what's the corresponding y? Why 6, Wenzel? I don't think so. I don't think so. I think it's just 3 comma, what's the y value? Boom. Let's go to 3 comma 3. I now know that point is also on my graph. Could I do this more and more and more? Yeah. Now, I don't think we really need to, because check it out. Once I have these 2, is there anything on this graph that I'll never touch? I won't touch the vertical asymptote, and I won't touch the horizontal. And can we all agree I will not touch the x-axis again? Like, we can't agree, or no, I won't? Okay. Am I certain that it doesn't turn back around and do this then? If it did, I would have found another x-intercept. But there's only one. So if it has to get really close to this line, I think the only way it can do it is that. And then if it just gets really close to this other asymptote, it just has to kind of mellow out, right? We can get it with points if you'd rather. My goal and what I would prefer is if we can get to a point where we can do it without all these extra points, it's a huge time saver. But we need to work to get there. So tie your boots. Let's work to get there. Cool. Questions here before we continue on? Kian, I think I cleared up your question. Is that true? Okay, we're going to do another one, but we're going to save a little bit of the work with it. Let's get one more. And by one more, I mean, let's do like a bunch more. Yeah. Okay. So here we go. Let's deal with the nice one. F of x is equal to... Oh, we can sneak in all this other stuff we're doing here. That works well. The numerator is x squared plus 2x plus 1. Yep. And I want to divide this bad boy by, x cubed minus 2x squared minus 3x. This is our lovely original form. What should we do to start before we even think about graphing it? Let's factor it. I want you guys to factor the numerator, factor the denominator. Let's get a nicer looking form. Let me know if you need help with the factoring stuff. I'll come speak with you. But I'm going to give you guys a minute first. You starting some factoring?
Yeah. Oh. Whoa.
So we have our original. I want the factored one, and then we'll have the simplified version also. Are you like end of the day still hung out? Did you forget how to factor? Seemingly.
No.
Oh, okay. Okay, you're good. Definitely was. Sound check. We're cool. All right. Right now, just to make sure we're here and we all agree on the language, this is my original. Okay. What's this one? This is my factored. And then is there anything nice that's going to happen? Let's get our simplified form, and we'll do this one in green. What simplifies here? In this expression. Like I want to simplify it, that's the goal. Does anything fall out? I have a common factor between the numerator and the denominator. It divides out. So my factored form leads me to my simplified form. What's left? X plus 1 over. Okay. Now I'm going to make a note here from this. What was the factor that we just divided out? Like, what did we actually cross out? X plus 1 was the factor that divided out. So I'm going to be very wordy for a minute. We divided out the factor x plus 1. I'm just making sure that we don't lose any piece of this. Everybody agree with that? If we wanted to find the root connected to this factor, to find a root, we take all of our factors and we set them equal to what? If we set this equal to 0, we now find the what from our graph. It is a solution, but look back. It's a solution to that one root for sure. But what does it mean if we had a root or a factor that divided out? What did it give us on our graph based on yesterday? There's a hole. So when we say we divided out this factor, we're going to make this other comment. The hole is at the x value, that makes whatever our factor was, and just now is x plus 1, equal to what? How do we go from a factor to a root? Louder? 0. Yeah, it's our root. So what that means for us when I come down here is I'm just going to start with that. We knew that there was a hole because we had a factor divide out. And I don't really care the order that these things show up in, but where did that hole happen just now? If we solve this equation, what do we get for x? Help me solve it, David. How do you move this to the other side so it's only x? So, do you agree with that? If I subtract 1 from this side and 1 from this side, do I just get x? Yeah, and that's what it really is. It's -1. There's our hole. So same thing as before, happened to be at the same spot. When we go to the graph at -1, we're going to have a hole in our graph. Okay, so I don't know why I didn't label this one. What is this one called? Original, factored, and simplified. Okay. Before we move on, questions about any part of this? Ken? So we're going to graph it just like we did yesterday. We're trying to do everything. Yep, we just need another example to really drive this home. Okay, what else do we need if I want to graph it? So VA, what's VA short for? Now, if I want to find the vertical asymptotes, I have 3 of almost the same. I have the original, the factored, and the simplified. Which one of these do you want to use to find the vertical asymptotes? Let's use the simplified version. How do you find vertical asymptotes? Are you sure? Okay. Are you sure? Okay, I am also sure. We set denominator equal to what? So let's do that. We'll do a little bit of scratch work. What are the things that are in my denominator right now? So what makes, and this is always a weird question, what value of x makes x 0? It seems like such a dumb question. It's the obvious answer. 0. If x is 0, and it seems so weird, but it's true, right? When x is 0, x is 0. And it seems like almost nothing. What value of x makes my other factor of the denominator equal to 0? And remember, when I'm looking at that, what I'm asking is if we had x equals 0, that one's done. And what's the other factor in the denominator? X minus 3, and we set it equal to what? 0. This is always how we find the vertical asymptotes. We've already gotten this one taken care of. If we solve this equation, what do we get for x? 3. I'll add 3 to both sides. And check it out. We get a vertical asymptote at x equals 0, and we get a vertical asymptote at x equals 3. I put the factors equal to 0. They're just the roots. Everybody still cool here? Okay. You're going to have to check your notes for this next one. Huh. See, yeah. All right. How do we find horizontal asymptotes? So be very careful. So everybody wants to default to the leading coefficients, and you're kind of right, but we have to check the degrees. Now, same thing as always. We're going to check. Should I look at the original? Should I look at the factored? Or should I look at the simplified? The original is fine. What's the degree of the numerator? So the degree of the numerator is 2. And I'm going to call that n for numerator. What's the degree of the denominator? 3. They're not equal, so it's not just the ratios. But you probably don't have this just locked in by memory. That's okay. Take 30 seconds, go back in your notes to when you looked at horizontal asymptotes. Like physically turn your pages, actually do it, and tell me if the degree of the denominator is bigger, where does our asymptote happen? So I want you to physically turn your pages also because I want you to find it. Like go back. No, you're good. Find me the degree test. Don't just shout it out. I want everybody to have to look in their notes to find it. You're trying to tell me where that horizontal asymptote is based on the degree of the numerator being smaller. Don't shout it out. If you look back to when we did HA, we did this whole comparison thing. If the degree n is bigger, cool. I'll give you a second. I'll help you find it, Kian. So let's look. Let's look to first time we mentioned horizontal asymptotes. I go back into the page because it's been a little while and you don't remember this, so I see it mentioned there. Oh, hold on. Horizontals. Yeah, this is what we're looking for. It's one of those 3 categories. I'm going to check everybody else's. So it's been a little while, but I see some horizontal asymptote stuff happening. I see some happening. Oh, hold on. Oh, hold on. Find VA and HA. So we're getting closer. Inverse variation. Oh, hold on. HA, compare the degree of these, and there's these 3 possibilities. What does it say to do if the degree of the denominator, D, is greater? If D is greater. Okay, louder. Y equals 0 if the degree of the denominator is bigger. Did you find that in your notes? Awesome. So now we know that there's a horizontal line that we get really close to. We have the whole here, vertical asymptotes. Other things I need. Let's find the x-intercepts. And the x-intercepts happen when which part is 0? So notice, process of elimination here, we're going to take advantage of this. We've already set the denominator equal to 0 to find the asymptotes. So what's the only other option? So give me a good answer. So set what equal to 0 is what I'm asking though. So pause. Pause. We're all going to zone in on this comment, okay? It's either the numerator or the denominator. We've already said that if it's the denominator, we're finding these. What must it be then? Nope, don't give me an answer. I liked your first answer, your first word. If the denominator tells us the vertical asymptotes, the only other part is it has to be the numerator. And if you look back at the same page that we're looking, we'll see the exact same thing. Set numerator equal to 0 to get the roots. A fraction is 0 when the top is 0. So we're just going to write it. And we're going to remind ourselves, because it's been a while since we graphed. Set numerator equal to 0. What's our numerator? And what are we setting it equal to? 0. How do I solve this for x? Subtract 1. I get x equals -1. Now, to make this look more like we did the other day, ladies, because I'm concerned that these all look the same, I want to think about this as the x-intercept as an ordered pair. We know that when I pick -1, it should spit out what? Since it's an x-intercept, a root, a solution, or there's one more word. 0. If there isn't any y, what do you mean? If you're finding the 0, the y is 0. That's why it's the solution when we set it equal to 0, is why we call it the 0. Okay. From just this, let's see what we have and pick some nice points. Questions here? And you're okay with it?
Yes.
Okay. Deal. So, what I want you guys to do, and if we have to move out of groups and stuff, we will. Just so you guys are aware. I mean, it's no skin off my teeth. I can teach the same whether you guys are in groups or not. Cool. I want you guys to make the scale for me. Pick your scale, put only this information on there. Catch up to here, and we'll decide what other points we might need. So you're going to draw your axes and the scale. That's what I want you to do. X-axis, Y-axis, and the tick marks, along with the asymptotes and such. I'm going to give you guys a little head start before I start drawing mine. So what's the line y equals 0 look like? Yes. So when I do it on yours, and again without colors and stuff, it's harder. I just do small dashes like right above the x-axis. Yes, ma'am.
So it says this equals 2, right?
So the degree is.
So would I put that?
So careful. This is just our check. This is the actual asymptote.
Oh.
And it's weird because it's going to be right on the axis. The way that I do this, and do you guys want me to do it with a pencil so it looks exactly like yours?
You like dash this line?
Yep, right above it. Right above the axis. So do it here.
So you do the same like
Yeah, would you do the same for this one? Or no, this
So
wouldn't.
what is this one?
X. This is X.
Yep, so I would just go to wherever -1 is eventually, and that's where my graph is going to be.
Why are we going to -1 if this is 0?
So we get the x-intercept by set numerator equal to what?
0.
And here's the numerator, set equal to 0. What x did we get?
Oh, -1.
Yep, so all of this, we're just showing the work in here.
We'll see this.
Yep, and make it a point so it's really clear also. And then now that that's -1, we already are set in for our other ones. Let's see. This is going to be a weird one, and we'll see why this is going to be a weird one.
Oh, because it's on the. Isn't it on the thing?
It looks like it is, and let's see that divided. Where are we? Is this our problem here?
Yeah.
This one?
Yeah.
Yep, we're okay with that. Yep, so we'll have to fix this in a while, but let's keep going.
What if the whole
Okay, so.
is on the x-intercept?
Better make it a whole. Yep. So let's just add the asymptotes, and that's where I'll catch up. Our scales could be different, right? And I don't know why I went so far, but I'm going 6 and -6. Only because I had my graph drawn this big. That's why I went that far. Okay. Where do I need to put stuff on here? I'll just go to 6 so it's the same. Give me one thing I can put on this graph. What do you mean -1? The x-intercept. So I'm okay to put that at -1. We're going to see something wonky happen with this here in a bit, but that's okay. I'll put it right away. I'm good with that. What else can we put on? Yeah, let's put our vertical asymptotes. Now, again, with mine, it's always going to be easier because I have color to do it. And just, Lucy, just so you know, I'm not going to dash them because I can make my asymptotes just pink all the time. Yours will be dashed if you're doing it with pencil. Mine aren't going to be. So here's the line x equals 0. Right next to it. I will not cross this. So I don't think you have yet. That's x equals 0. That's this line. Where's another vertical asymptote? So x equals 3 is right in between. Here's the line, x equals 3. That's my other vertical asymptote. So you were right. I think I just haven't done the other one yet.
Oh, never mind. Wait, no, never mind.
I think I know where you're getting goofed up. I think you're goofing yourself up because you drew this one, and now you're saying, wait.
Because this is confusing me.
So this is our scratch work. This is the actual asymptote.
Okay.
Remember, this means implies.
Yeah.
So it's because people are struggling to tell me this, is we just did the work in here. Like, if you need to box this is the horizontal asymptote.
Yeah, but then why is this 3?
Because this is the line where y equals 0. Like, check it out. Here's y is 10.
So it has nothing to do with this.
5. Nope. Vertical and horizontals are different lines. So we can have this one be y equals 0, and we have x equals 0. It's just this line. X equals is always vertical. Y equals is horizontal. You're getting goofed up because you see y equals 0 and x equals 0. You have y equals 0 drawn. And I'm going to draw x equals 0 now. So we should have how many asymptotes? How many y2? Good. 2 vertical and 1 horizontal. Okay, at this point, are we still all cool with it? Okay, so let's clean up the rest of it. We have all of this information. Now, I think that I'm going to also struggle a little bit to see exactly what this graph does. Would some extra points possibly help? Now, last time we did it as F and we just made a thing there. Would you rather make an actual table so it looks like all the other regular graphs? Okay, so it is a style choice. I'm going to keep that function there. I'm going to use the simplified version. We're going to make a small table just to get our value so it looks a little nicer. So let's try that. And we'll slightly different approach. We're doing all the same math. I'm going to make X, and I'm going to plug it into the simplified form, this guy. And I just need to know what Y's they spit out. And we just need enough information to get some points. So right now, we only have 1 point on our graph, and it's at -1. And you guys notice there was something weird about -1. What was the weirdness that happened at -1 that gave Kian pause? There's a hole at -1, but we also just put our root at -1, right? So let's decide what it does. I'm not going to choose -1 because I know it already broke my function. So I need any value that's not -1, not 0, or not 3. Anything not on this asymptote. So 4 is reasonable. That's like right here, right? So let's try it. If I plug in a 4, and I'm going to try to do a little bit shorter work just to save time, let's plug in 4 for every single what here. So let's do the numerator. What's 4 plus 1? Over, and I'll do 2 steps. There's a 4 times, what's 4 minus 3? 1. So that's 5/4. 5 over 4. Now, you can keep it as 5/4. If you're graphing, I'm okay with it. That decimal is 1.25. And it helps to get decimals when we're graphing. Now, what I know is that when I go to x equals 4, which is roughly here, what's the y value? Not where my cursor is, but based on what we just did. If I pick 4, what y value does it spit out at me? It's this, right? These are our ordered pairs. Our x comma y is right here. So if I go to 4, which is about here, 1.25, would you believe it's right there? Now, I'm not doing it like super precise, but it is right here. Kian. Because did you know before that it was up here like this? This is the ordered pair 4, comma 1.25 that we just got from our table. We know what this 1 point is, don't we? So like right now, Kian, before we did that, can you tell me if it does this underneath or if it does this above? No, right here. Right here in this region. Before we graph any of it, you don't know if it's stuck down here between those two asymptotes or if it's stuck up here between these two. So don't care about the left right now. We're only looking at the right currently. You don't know yet, right? But as soon as I put this point, is it above or is it below? It has to be above. Now, if that's not clear yet, give me another point somewhere else. We did 4. What's the next natural choice? 5. What's 5 plus 1? Over 5 times 2, 6/10. It means when I go to 5, I get 0.6, which gets a little bit lower. Can you tell me what the graph has to do in that very rightmost region right now? Can you tell me, and rather than saying it, because it can be hard, I want you to draw what you think the graph does only in this box. Don't draw the box on yours. Draw me what you think it does based on those 2 points. And I want you to physically sketch it. Just do it light so that if we have to erase it, we will. We'll fix it. But I want to see if we're having like small little issues, we're going to find out exactly what's happening. You're okay. I'm not trying to rush you. You know it has to pass through those 2 points, right?
Sorry, this is my point. It looks a little weird.
You're okay. So you said it goes down like this?
Maybe.
But then it has to,
Guess.
can it cross this one?
Yeah, I think no.
Huh.
No, because you
So
said.
it can't do that. So it has to turn up here. And then we're going to look at something. So whether you're right or wrong, I don't care. How do you think it goes through that point? And there's another one right here that's just really low. So put a point right there at the tip of mine. It has to go through these two. And it can't cross the vertical line right here. Or right here, sorry.
Just go. Boom.
So it goes like that. And how about on the good? So, what's up? Why did we start with 4? Because it's the first number that somebody gave me. I'm picking any numbers that aren't the asymptotes because we're just trying to figure out what's going on. So show me your graph. This? So I love some
I
of
think
it.
it's too big.
What can't you cross?
It has to-
What did you cross?
it has to-
Good. So we got to fix something. So check it out. This logic, and we're going to hit it again. So am I ever going to cross this? Okay. How can I assure you 100% that it doesn't do this? What would we have found if it crossed there? So I'm still going to make you answer, though. Check it out. If I stop right here, I think it's where the issue is. What would I have found right here at this number? What am I touching? Which axis? How many x-intercepts did we find, though? Are you sure? It's only the one at -1. Is it ever going to cross over here then? So if it's not going to cross, even with just 1 point, I think we could have made this decision. I know it gets really close here, and if it's never going to cross, it must just flatten out. Like, that's the logic that I've been using, and I'm glad. I think it might have just finally clicked like clearly in your brain. We're going to get everybody. Okay, it has to be that region. Anybody know what's happening in the middle? It's probably curving. Why can't it do this? There's no x-intercepts there. So we have two options. Everything is either positive and above or negative and below. As soon as I know if it's a positive value or a negative value, anywhere between here, I know if it's entirely above or entirely below because it won't cross the x-axis. Guaranteed. Only place it happens. So pick any number, preferably the easiest, somewhere between 0 and 3 that will plug into our function.
1.
Good choice. Let's try 1. So we're going to use our table to get another point out of this. If I plug in a 1, what's the numerator become? 2 over 1 times, what's 2 divided by -2? Try again. -1. Follow-up question, what point did we just find? There's an ordered pair that we just discovered here. So if I go to 1, I know it's -1. So that point's like here. Is it ever going to cross the x-axis in this middle region? How do you know that, y'all? How do you know no? Because I agree. Okay, so how do I know that it won't ever cross the x-axis, even if you didn't say anything? What would we have found if it were going to cross? Instead of cross, is there another word we could use? Instead of where does it cross the x-axis? Maybe another word. Touches works. Intercept will also work. That's kind of what I was looking for. This is the only place it ever crosses, right? Can't get a read on you guys. It's so hard to tell today. Not until we finish this. We're not stopping right in the middle. Not a chance. How do I know it's not going to cross like this?
Because it's going to touch that.
Nope, we're here. We're here first. Time out.
Sorry.
It's going to touch what, y'all? So, okay, so we're going to refine it. Okay, so I'll make it so it doesn't touch the asymptote. How do I know that it's not this graph? Don't care about the horizontal. Y'all said it like 4 times already. So we're not focusing on the asymptote. X-intercept. How many are there?
1.
And maybe this is where the issue is. What is an x-intercept? What does that actually mean? No asymptotes needed. Don't talk about asymptotes. What's an x-intercept? What does it mean to intercept the x-axis? To cross it. And I'm okay with that. Does this graph cross the x-axis? And based on the way I drew it, it's roughly at, if that's 0 and that's 3, it crosses at like 1.5, right? But where's the only place that we said it's going to happen? Can it happen in this middle region? -1 is not between 0 and 3, right? This is the only place it can ever change signs or cross the x-axis. Which means if I already know that this one's negative, if it can't cross the axis, what's it have to do? It can't keep going up because it'll cross it. Oh my goodness, it just goes back down. There's the middle section. Like, for real, each one of these pieces, and we're going to just drill these until we have to. You're not going to love the homework that I give you tonight. For these, the intercept is king. What's the x-intercept again? What does the graph do at the x-intercept? Crosses what? The x-axis. Okay, we don't always do this. We're going to try it. You guys are going to repeat after me. You're just going to answer this question like 10 times. What does the graph do at its x-intercept? I'm okay with crosses. We know that it doesn't really cross. If a function touches or crosses the x-axis, we just found it's what? It'll only switch signs or go from positive to negative if it crosses over a... I'll take axis, but I was looking for x-intercept. This is the only place that it will ever possibly change signs. It means that once I know it's negative, I'm guaranteed it's negative everywhere here. Once I knew it was positive, I was guaranteed it was positive because it's never going to change. Okay, we have one more region. I think I know what the graph does, but let's get a couple more points. I'm picking anything to the left of which x value.
What do you mean anything to the left?
So we need to know what's going on over here, right? -4 would work. -5 works. I would choose -1, but we can't pick that one. What's the next nice one? Let's try -2. And help me plug it in. What's -2 plus 1? -2 plus 1 is not 2. It's -1. Over -2 times, what's -2 minus 3? Try again.
Wait, -2. Those are 2.
-5 it is.
Oh my God.
What does this come out to be? -1 over what? -1/10. What we just found was that -2, is my point going to be above the x-axis or below it? Barely below, right? -1/10. Okay, with these 2 points, I think I know what's going to happen. It can't cross again. That's okay. Eventually, it's going to get really close to this horizontal asymptote. Now, we don't know exactly what it looks like. It's going to do something wonky. It's going to do something like this is kind of my guess. Now, 2 options. It either turns around like this suddenly and never touches the x-axis, or it curves up through. How do we decide which one? But we've already tried to place this one. How do we make this determination? So, but we've seen graphs where, like a parabola that does this, right? It touches and turns around. We've seen that happen. It could do that, or it could do this and keep going up. It shouldn't what? So, we're going to tie in another idea. Have we ever used the word multiplicity? How many times did our x-intercept show up? 1 time. This showed up 1 time in our solution, right? We didn't have to write it twice. Is that 1 number of times, even or odd? Odd. If it's odd, we cross. So I know it crosses. It crosses. And we could check another value. Because why? Because the multiplicity is odd, and I know it happens. Give me an x value between 0 and -1 that we could check to verify that. Between 0 and -1 if we wanted one more. -1/2 would do it. I encourage you to do it. You're going to get a positive. Now, this graph's kind of ugly. That's okay. There's one last little tiny change we need to make. And then tomorrow, bring your graphing hats because we're graphing like all day long. For real. Cool. Where's the hole?
-1.
Well, that's right here, right? Done. I just made a big obnoxious hole there. It happened to be at the root because it fell out. If you don't like that, that's okay. Because we have a place on our function where it's not defined. So if you can't even tell me, like if it doesn't make sense to say what number is it, then you can't have it be a number.
Okay.
Like same thing that the asymptotes happen when we divide by 0. We don't know what it is, so we can't get that. Holes are just a little bit different. Okay. Tomorrow, be prepared. We are graphing like all day long. Maybe brain break. Probably brain break. Be valorous for the rest of your day. Sure, yeah, brain break right now. You know what? I'm feeling real good. Let's do like a 15-hour brain break. 15 hours. Cool.